Now, given a sequence of random numbers, compute exponential variance xi for lambda is equal to 1 and 5 random numbers are given to us. So, we know that exponential variate equation is minus 1 by lambda ln Ri. So, the same thing here, minus 1 by lambda ln Ri. So, lambda is equal to 1. So, when lambda is equal to 1, I am going to substitute this value in this equation. So, it becomes minus ln Ri. So, ln of 0.1306 is minus 2.0356. So, the value 2.0356. So, in the same way, I am going to also calculate x2, x3, x4 and x5. So, these are the 5 different values for random variance when the random variant is exponential variant. Next question is applying inverse transform technique for uniform distribution. So, in uniform distribution, probability density function f of x small f of x is equal to 1 by b minus a, where x is between a and b, whereas a less than or equal to x, less than or equal to b. 0, otherwise f of x will hold a value 0 if x doesn't lie between a and b. So, here always we know that probability density function is small f of x, okay, small f of x, where f of x is equal to 1 by b minus a. So, I am going to generate an equation for cumulative density function. Always cumulative density function is capital F of x, capital F of x. So, capital F of x is equal to integration of probability density function, where lower limit is a and upper limit I don't take another constant, I am just taking x as we did in the previous transformation. So, here f of t dt. So, small f of t dt is nothing but probability density function. So, here I am going to integrate probability density function in terms of t, where lower limit is a and upper limit is x. So, f of t is nothing but 1 by b minus a. So, the same 1 by b minus a is written here dt. So, 1 by b minus a is a constant. I will remove it outside and I am going to integrate dt. So, when I integrate dt, it is t. Integration of dt, lower limit is a, upper limit is x, is nothing but t with both the limits. So, apply these upper and lower limits here, you are going to get x minus a. So, the equation is x minus a by b minus a. So, this small x I am going to convert it into capital X. Capital F of capital X is equal to random number r. That is nothing but capital X minus a by b minus a is equal to r, where x minus a is equal to r into b minus a, x is equal to a plus r into b minus a. This is the equation for random variable, where the random variable is uniformly distributed. And here you have to always know what is lower range and upper range for this particular equation. Substitute x is equal to a in x minus a by b minus a equation. This equation you will get this as a minus a by b minus a, that is nothing but 0. So, this equation will apply for a lower range of 0 and upper limit, apply this b into this equation, b minus a by b minus a. So, it is nothing but 1. So, upper range for this equation is 1. So, x is equal to a plus r into b minus a, where r is less than or equal to 0, 0 is less than or equal to r, less than or equal to 1. This is the equation for random variable if the random variable is uniformly distributed. Next one is Weibull distribution. When it is Weibull distribution, The PDF for Weibull distribution is given like that, like this. Small f of x is equal to 1 by alpha to the power of beta e to the power of minus x by alpha whole to the power of beta, where 0 is less than or equal to x. Otherwise, the PDF value is 0. So, always again, cumulative density function is indicated by capital f of x, and that is nothing but integration of the PDF in terms of t, and lower limit here is 0 and upper limit always is x. So, f of t dt. So, here f of t is nothing but 1 by alpha to the power of beta e to the power of minus x by alpha whole to the power of beta, where it is in terms of t. So, I am replacing x by t dt. So, here 1 by alpha to the power of beta is a constant. So, I am going to integrate only e to the power of minus t by alpha whole to the power of beta, that is nothing but e to the power of minus t by alpha whole to the power of beta divided by 1 by alpha to the power of beta, where lower limit is 0 and upper limit is x. Substitute lower limit and upper limits. When I substitute upper limit, I will have minus e to the power of minus x by alpha whole to the power of beta minus e to the power of 0. So, that is nothing but 1. So, I am going to get this equation. So, capital F of x is equal to R. Always equate. This is the second step of inverse transform technique, where capital F of x is equal to R, where small x is always replaced by capital X. So, this is the equation of capital F of x, that is equated to R, and now I am going to get equation for x in terms of R. So, x is equal to alpha multiplied by minus ln 1 minus r whole to the power of 1 by beta. For how I will decide this limits 0 less than or equal to r. Substitute lower limit in this equation 0 into this CDF 1 minus e to the power of minus x by alpha. In this equation, when you substitute in this equation, you are going to get 0. So, 0 less than or equal to r. This is the equation for Weibull distribution.